My name is Tom Hackett, and I'm a group campaign marketing director at Cadence serving the IP group. So let's get started. Today's presentation is called Build the Future Faster with Cadence IP. And what we want to do is take a look at some of the forces driving commercial IP adoption. So what do I mean by commercial IP? Well, there's the IP blocks that you develop inside your group. Those are your own internally developed IP. And if you purchase IP from a commercial vendor, well, that'd be commercial IP. So there's factors that are causing people to go out more and more for commercial IP. And there's three of them. And the first one we're going to look at is the SoC development cost. Now, we've all heard these staggering numbers of how expensive it is to design chips today. But let's try to put this in perspective a little bit. If we go back a few years to the .com era, say around the year 2000, it was a lot less expensive to build these chips. So does anybody have a guess? How much money would it take for a startup to go from concept to first silicon back then around the year 2000? How much money? Any guess? Throw out a number. $500,000. $500 million. Okay. Well, let's kind of cut in the middle of that and say about $10 million. That's about what it took. Was anybody here in Austin back at that time, around 2000? Yeah, okay. So there were a lot of semiconductor fabless startups here in town back then. It was kind of a golden age for those startups here in Austin. And that was the reason, because for $10 million, people could get that funding and hire a team, get their tools, get started, and actually get all the way to first silicon. And that would be like, then they're either going to succeed or not at that point. But let's take a look at this. Right now, today, the 28 nanometer node is considered that's like the mainstream node. And look how much money it costs. It's about $100 million for a large SoC in 28 nanometers. At 20 nanometers, it's up to $150 million, and at 16, over $300 million. And let's not even talk about 7, right? It's a lot of money. So what does that mean? It means that failure is not an option, right? That chip has to come out on time, and it absolutely has to work, or it's pretty much game over, right? So the high stakes are one of the first items that come into play that are going to relate to IP. The next issue is the high amount of semiconductor consolidation that we've seen in just the past 2 years. That chart shows the total value of companies being acquired each year. And so it was steadily under the $50 billion a year mark. But in 15 and 16, it went way up over $100 billion a year worth of mergers and acquisitions. Now, certainly there's many reasons why that took place, but one reason is that companies became increasingly difficult to differentiate their products from the competition. And this is true at the system level, and it's true at the SoC level. So for development teams, SoC development teams, the idea was, okay, you need to have a differentiated product in order to succeed. And because of the money involved, it's a very, very, high-stakes proposition. All right. Now, if that weren't enough, there's a technical force that's coming into play here also. And that deals with the SoC interfaces themselves. So what we've also seen in the past several years is kind of an explosion in the variety of standard interfaces that can connect to an SoC. So we've seen different versions of the same interface, multiple versions of PCI Express, Gen 1, 2, 3, 4, of DDR 1, 2, 3, 4. We've seen these interfaces go to a higher speed level. So you have a lot of issues that come into play with high speed design that you didn't have to deal with before. And then there's sort of a expansion from the core interface to get other functionality in there. So like for USB, for instance, how many people have a USB Type-C product that they own? Cool, yep. I just got myself a laptop. I love that, the USB Type-C. But so that not only carries the USB data, but it carries power to power up to other devices on your desktop, up to 100 watts. It also tunnels DisplayPort, and you can tunnel other protocols. So all of this translates into a lot more complexity for the SoC designers to have to deal with, okay? And that complexity means more time, more focus, more energy, maybe more people devoted to handling these interfaces. But wait a second, these are standard interfaces. And we just said how important it was to be differentiated. And so why would you want to spend engineering resources on standard things that do not differentiate your chip, right? So all these forces collectively have a big impact in the IP market, and they're driving commercial IP adoption. Now, there's a number of benefits to be had here from commercial IP. So one is you can take those limited engineering resources and focus them on the things that are going to make your product differentiated. You can access new technology, these new interfaces like USB Type-C, without having to pioneer it yourself and thereby lowering your risk. You can also get to market faster, and then you can tap into the embedded knowledge of the industry. And this is kind of an abstract concept, but when you think about it, when Cadence supplies IP to multiple different companies, and we learn things from each application, and we build that into the IP product, so the next customer kind of benefits from the experience of everyone who's gone before with that IP, right? So that's another benefit. But now these are my words. What do customers say? Now here we've got some quotes that we've heard recently from major customers. One quote, USB will no longer be developed in-house. It's the start of our outsourcing policy going forward. Another quote, design teams will be reserved for the most differentiating IP. The rest will be outsourced. And complexity is driving us to outsource IP, starting with PCI Express 4.0 and C6. So if you're going to outsource IP, and if the stakes are very, very high because that chip has to work, and it has to work the first time on schedule, well, what IP vendor would you go for? Well, I'm going to give you 5 reasons to think about Cadence as your IP vendor, as your partner. And these 5 things are unique to Cadence. So if you look at the first one, it's breakthrough technology, and then our comprehensive solution, the unique partnerships that we offer, our revolutionary tooling, and our visionary approach. So when you take these things and combine it with your knowledge and your resources and your creativity, that will enable us to build the future faster together and to deliver the cool products that people want. So let's look at these items. The first one is breakthrough technology. And let's face it, it all starts with a technology. So Cadence had the first DDR IP tape out in 7 nanometers. We delivered the first silicon-proven DDR4 and LPDDR4 running at 3200 megabits per second. And also, we have the fastest 16FFC LPDDR in the lab, which running at 4266 megabits per second. In the enterprise area, just last month in May, Cadence was first to announce support for C6. And who knows what C6 is? Can you tell us? Exactly, acceleration over PCIe, cache coherent interconnect for accelerators. It's an important new standard for data center applications. And PCI Express Gen 4 interoperability, we demonstrated this, that Gen 4 is 16 giga transmissions per second. We demonstrated that a whole year ago with Mellanox. And another area, in automotive, and is anybody in this group involved in automotive designs of any kind? All right? So automotive is a major, thrust in the industry. Well, Cadence had the first ASIL B-ready automotive Ethernet with time-sensitive networking, and also the first ASIL B-ready 16FFC multi-protocol 16 gigabit per second SerDes. All right, that's a mouthful. And as a marketing guy, try putting that into a Google ad. Okay, that's pretty tough. But anyway, these are just examples of some of our breakthrough technology. The second item, our comprehensive solution. So this, we don't just give you the IP, we give you an integration kit to go with that. And the integration kit includes application-specific synthesis scripts and place and route constraints to help you with your integration, IP exact views to enable a correct by construction integration approach. We help with quick system bring up by providing example drivers. And we have a SoC reference design that serves as a roadmap that you can follow. And also we deliver IBIS models that are correlated with silicon to enable board-level signal integrity analysis. And because of the high-speed nature of a number of these interfaces, that signal integrity is a really big issue. Another thing that we provide is support, and support that runs from the architecture stage down through the prototype bring-up stage. So our architectural exploration assistance can help you avoid, fundamental implementation pitfalls. We have hands-on experience with IP characterization, so that can help also guide your implementation decisions. Our protocol expertise is important because, as we talked about, these protocols are pretty complex these days, and you need somebody that really understands the issues and the trade-offs with the protocols. And then our evaluation board design experience can help you as you're trying to do interconnect, compliance testing, interoperability testing with your customers and partners. In terms of unique partnerships, we've got a couple that are very important. TSMC is a very important partner for Cadence. And in the past 3 years, we've received 8 Partner of the Year awards from TSMC, and 4 of them just last year. And they're listed here. And we're especially proud of the 7 nanometer awards for the mobile design platform and the high performance computing design platform. Another important vendor for any SoC company is ARM. And this pictorial over there represents a IoT reference board that they supply to customers. It has an FPGA on it that allows people to prototype their IoT designs. And we have Cadence IP is in that reference design. Now, a couple years ago, we signed an agreement with ARM where we could do interoperability of each other's IP, okay? And so the idea was to pre-verify things so it's easier to bring up a design. Now, ARM kind of tested this principle. Did that really work? Well, they took that reference board, and they had a small team of 3 engineers to take that and turn it into silicon, sort of like a test case. Well, that used our IP and their IP, and it took those 3 engineers only 3 months to go from RTL to GDS2, which is pretty great for any SoC design. So this interoperability really does pay off for customers. And then talking about customers, we work with some of the most advanced customers in the industry. In fact, 9 of the top 10 semiconductor firms use Cadence IP. And by working with these leading customers and paving the way through some of the really challenging technical issues, that then again benefits all of our customers that use that similar IP. The next issue I talked about was Cadence revolutionary tooling. So I guess it comes as no surprise that our Cadence IP developers would also use Cadence design tools in the process. Well, it turns out that this is a pretty big competitive advantage for us because of the major strides and innovations that have been developed in the tools part of Cadence. What we see here in this flow is our digital implementation flow. And we have, at every point in the process, massively parallel engines that run these tools all the way from synthesis through implementation, the place and route, and into the sign-off tools. So you might have heard and seen the banners of our Pegasus physical verification system. Massively parallel, greatly reduces the time it takes to do the final physical verification of your design. So that's one advantage. Another thing is our unmatched analog and analog's mixed signal expertise. So with all these high-speed interfaces, if you want that PHY to work, you really better have the analog details down and working correctly. Another thing is for digital functional verification, have some breakthrough simulation engines there. I'm sure you know of our Palladium hardware accelerator, our Protium FPGA prototyping system, Jasper Gold, which is the #1 formal verification tool, and also our new Excellium digital logic simulator that's unmatched in terms of speed. It's multi-core implementation, very fast. If you want to know about Excellium or Pegasus or the other tools, please visit us in the Cadence booth. We also have advanced IC packaging and board level expertise. Again, very important for the signal integrity analysis. And we employ a comprehensive verification methodology that we run all of our IP through before it gets to customers, because we know cost of bugs is very high and we want to eliminate those. And then the last thing of the 5 differentiators is our visionary approach. So Cadence is all about system design enablement, and that means a continuous development spectrum from IP to SoC to package to board to system for the target application market that you're in. And most importantly, we know that for us to be successful, we need to make our customers successful. And so to focus on your success, we give you the high quality IP, we give you high performance tools, we have the knowledge of these different target markets to help you be successful. But most importantly, we take a partnership approach to work with you together. And that's why we like this phrase, again, the build a future faster together. If we take a look at the different markets that we're focused on, there's 3 major markets for IP: data center, mobile, and automotive. And each of these uses similar interfaces. PCI Express could go across all 3. USB, DDR goes across all 3. But the needs for each application area are different. So in the data center, it's all about bandwidth and latency and reliability. In mobile, it's power, small footprint, and performance. And then for automotive, it's safety, reliability, and bandwidth. Or as the automotive engineers say, the top 3 concerns are safety, safety, and safety. So if we sort of drill down in here, we'll take a look at the data center solution. And our focus for data center is earliest availability of high bandwidth, low latency protocols. So for instance, like the PCI Express 4.0, like DDR4 at 3200. The process nodes that are particularly important are 16 and 7, and optimizing the IP for RAS, which is the reliability, availability, and serviceability, which is so important in server applications. The items in red are the major IP blocks that we have that serve this area: DDR, PCI Express, SAS, SATA, the various kinds of USB, various speeds of Ethernet, and then flash interfaces. The blue highlights are our Tensilica DSP IP. Who's familiar with Tensilica digital signal processor IP? Okay, it's very widely used. Actually, I'm showing here on the left Tensilica in solid-state drive acceleration. So Tensilica IP shows up in more than 45 different brands of solid-state drives. Little known fact. If we take a look at PCI Express in particular, and our PCI Express solution has been now expanded with our May announcement to include C6. So we deliver high bandwidth because we deliver a multi-packet design allowing a 95% or better link utilization. Our flexible PHY configurations are there to maximize the utilization of that bandwidth. And we enable faster ARM integration with our AXI reordering capability. There's lower latency that applies to both the Gen 4 PCI Express IP and the C6 IP. And as I said before, many features embedded into the IP that get to this reliability, availability, serviceability capability, and then other benefits. If we take a look at the mobile solution, the number one thing here really is power. And then the other number one thing is performance, because they're both like equally important, right? Nobody wants the new phone, if the battery's not long enough. Nobody wants it if it's slower. So the issue then becomes, how do we tune that trade-off between power and performance? And ever shrinking the area, because the amount of real estate available to the silicon continues to shrink. And then all that means, well, you pretty much always have to be in the most advanced process node to make that work. Now here in the mobile space, you see lots of different interfaces, most of which we have covered with the Cadence interface IP. And then we have 3 different areas of application for the Tensilica DSP IP. In hi-fi audio, which Tensilica, if you have an electronic product that you can carry around with you that has audio, it probably has a Tensilica processor in it. Vision is a growing area for Cadence. We have a very complete lineup of vision processing applications for Tensilica, and also for sensor fusion to combine the data coming in from different sensors. To take a look specifically at the DDR, the LPDDR, our LPDDR4 solution achieves 4,266 megabits per second without the need of voltage overdriven IOs. We enable hardware dynamic frequency scaling for flexible power management. And our mobile optimized PHY is very small and flexible to help you optimize the placement of your chip. Regarding that 4266 capability, you might think, well, I don't really need that now, right? But the thing is, if you have let's say you're at the 3200 mode. So if you take our IP, put it in there, it's already good for 4266. Then later on, when you do need to change that, you're not going to have to change that IP block, right? You're sort of building in, future-proofing your design, as they say. And the last area, if we look at automotive, all of our IP, remember, safety is the big thing here. So all of our IP goes through the failure mode effects diagnostic analysis process and earns an ASIL rating. And our IP is rated at the ASIL B level of readiness. All of our physical IP goes through the AEC Q100 testing, and our IP is validated to a grade 2 temperature range. We're part of the TSMC 9000A Automotive IP Quality Program, and we deliver all our IP in the 16FFC process, which is the sort of like the go-to node for automotive applications. So an example here in this space would be Ethernet. One of the big challenges in automotive design is reducing the amount of cabling. So in cars, there's hundreds of pounds of cables that go into your car. And of course, that hits your fuel economy. It's more expensive to build that car, a lot of negative things. So there's a benefit by going to a networked interface, and Ethernet is the example. But that brings a lot of concerns in about latency. And can I get, data, where it needs to go to the controller fast enough to make sure that we'll overcome any safety issue. And so therefore, it was very important, and Cadence was a leader in getting time-sensitive networking features into the Ethernet IP for automotive applications. And that's silicon-proven mature IP that's in use in various products today. Okay, so to summarize, there are 5 things that make Cadence a unique partner for IP. It's our breakthrough technology, the comprehensive solution with the integration kit and the support, our unique partnerships, TSMC and ARM, revolutionary tooling in both the digital, analog, functional verification flow, and our visionary approach, meaning system design enablement and a partnership that puts your success first. So with that, that's Cadence IP. We invite you to plan your next project with us so we can work together. If you want to learn more, we have over at the Cadence booth in our expert bar starting now an IP expert bar session, and you can talk to our experts and learn more about our IP solution. So thank you.
Thank you, Tom. And you can search and explore all of Cadence IP on ChipEstimate.com.